Hi, good afternoon or good morning or good evening, depending where you're joining us from today. And welcome to another episode of the 3D Friday Talk Show. I'm your host, Michael Petch. I'm the editor-in-chief of 3dprintingindustry.com. And I'd like to thank Free Your Mind, as always, for organizing this event and finding some fantastic speakers to talk to us about the topic of sustainable 3D printing and whether that is a myth or reality. So if you're unfamiliar with Webinar Jam, we'll do a brief spot of admin before we get into the main event. You'll notice on the right-hand side of your screen, there is a chat function. So please do use that to introduce yourselves to each other, but also, even more importantly, to put questions to our guests today. We'll be taking questions throughout the show, as always, and we will be breaking up the topic into 3 easily manageable chunks, and we'll be taking questions after each of those sections of the topic are discussed. So please do fire your questions away in the chat, and that's on the right-hand side of the screen there. So, okay, what do you think about when you hear the words sustainability and 3D printing? Well, the cynics in the audience may assume that anyone tackling sustainable, green, or the circular economy and using those, what some might call buzzwords, could be a cynical marketing ploy or an insincere attempt to harness the zeitgeist. And we're going to be maybe challenging a few of the frequently made assumptions that, does AM really use less material? Does it actually produce less waste? And also maybe looking at a bit of a reality behind what about these initiatives about collecting waste materials such as PLA scraps and looking to recycle them into additional filament? Is that something that really can be done? And I think it's important really as an industry that we do go beyond the superficial. And maybe as part of that conversation, we need to consider, well, are we thinking too small as an industry? And are these incremental small-scale adjustments merely a Band-Aid on a mortal wound? And are more radical solutions actually required? Now, without further ado, I'd like to sort of present the people who will be able to hopefully tackle a few of these questions today. And our guests are very well placed to strip away this veneer of marketing, and as they are coming from academic and research backgrounds, both within and outside the additive manufacturing industry. So without further ado, guests, could you please join us? Here we go. Excellent. Thank you all for taking time out of your busy schedules. I imagine there's a lot going on in the world out there that you can all be involved in at the moment, and joining us for what I hope will be a fruitful hour of discussion. So I'd just like to introduce everyone briefly. We have Sherry Handel from the AMGTA, who's joining us from the AM sector. We have Ian Cronin, who's from the World Economic Forum, and we have Emma Fromberg from the University of Cambridge. So, Sherry, could you maybe tell us a little bit more about yourself and what your organization does, please?
Sure, Michael. It's great to be here. I'm Sherry Handel, Executive Director of the Additive Manufacturer Green Trade Association, also known as the AMGTA. And the AMGTA was formed last year at Formnext, and I came on board last February as the first Executive Director. And the AMGTA is a global and unaffiliated nonprofit organization open to any additive manufacturer or industry stakeholder that meets certain criteria relating to sustainability of production or process. So my role is to build this new industry trade group globally and to work with our members to take on the sustainability challenge in AM.
Thank you, Sherry. And Ian, it must have been a busy week for you, just coming off the end of the Davos forum that's just concluded. And perhaps you could tell us a bit more about your work in the WEF if people aren't familiar already.
Yeah, absolutely. Thank you so much for having me. It's great to be here. So for those who don't know, the World Economic Forum is an international organization based in Geneva, Switzerland, focused on international cooperation between public and private sectors with the broad goal of improving the state of the world. Within that context, I work for what is called the Platform for Shaping the Future of Advanced Manufacturing and Production. We didn't get any points for being concise in the title, but we do cover a lot of areas, really looking at what's the potential of manufacturing in the future to drive a greater good economically, socially, environmentally, and what do we need to do to get there. And so within that context, I lead our portfolio on sustainable manufacturing and our regional engagements around the world. So I'm really excited to be here and dive into the additive manufacturing and sustainability topic with this fantastic panel.
Great to have you here, Ian. And finally, Emma, you're just up the road from me over in Cambridge in the UK. So perhaps you could tell us a bit about your work, please.
Thank you so much for having me. So I'm Emma Fromberg. I'm the course director in sustainable business at the University of Cambridge Institute for Sustainability Leadership. And I do have a background in industrial design engineering, and I know a little bit about 3D printing, which we're going to talk about in a bit. But in my current role, I focus on the role of businesses in reshaping a future economy that should be regenerative, abundant, and inclusive by design. I lead 2 postgraduate programs in sustainable business, a certificate program and a diploma. And all our students work full-time in business while studying part-time, and they apply all their assignments to their own business context. So through these programs, we try to empower them to take action within their own sphere of influence.
Marvelous, and thank you all for joining us again. So, right, our first topic is going to be 3D printing and sustainability in manufacturing here. So, I think we're going to set the scene a little bit and talk about some of the general ideas we're going to get more into later on. But perhaps Emma, actually, maybe you could tell us a bit more about your insights and how 3D printing links into sustainability.
Yeah, sure. So I think the unique feature of 3D printing is the distributive nature of the technology, which makes it really good to discuss when looking at manufacturing in general for a more sustainable economy. In most of my work around sustainability and circular economy, I focus on the systemic nature of the problem as well as the solution. And this means that we cannot just look at environmental sustainability without looking at the social implications. And in the end, it's all interconnected. And very often I refer to the difference between effectiveness and efficiency. And I think this is really important for the debate and to frame the debate. And I think the author of the thinking around cradle to cradle actually describes it perfectly. And efficiency is, he says, efficiency is like, if you normally hit your child 10 times a day, if you're more efficient, you will hit it 8 times a day instead of 10 times a day. Effectiveness is actually looking at how can you provide a nurturing childhood for your child. So I think it's very helpful to look at effectiveness, you know, that nurturing childhood, rather than looking at like, oh, am I going to hit my child 10 times or 8 times today? And I think that's really important for framing the debate. Very often the 3D printing conversation in sustainability is focused on efficiency and agility of production. But I do believe that the more interesting features touch upon more that distributive and democratic nature of the technology.
Thank you. And Sherry, would you echo this, or how do you see 3D printing as part of this wider conversation?
Well, I want to just start by saying it's really exciting to see what's happening in the AM industry. There's a lot of excitement about sustainability, and companies really want to strive to improve their eco footprint. And the key for us is to really help as a resource to our member companies and industry as a whole to rise to this challenge of improving sustainability in AM. So the key is that the economic and technical superiority of additive manufacturing is certainly well known within key industries, but its environmental sustainability benefits are often less well understood. And so there are several key positive environmental benefits of AM processes when compared to traditional manufacturing. And most notably, there's considerably less waste. But the big challenge is that existing research on sustainability in AM tends to focus on silos of energy use, waste, machine emissions, and there really isn't a more encompassing, full, holistic look, life cycle assessment, which we'll be talking about later. And we really need this data to be able to really stand behind what we're saying in the industry, that this is a more sustainable technology. And here's why, because we can prove it. So the flip side of any challenge is an opportunity. And so that's where the opportunity is to provide solid and reliable sustainability data and metrics. And companies can support independent, rigorous, and ongoing research by supporting us as an organization to help do that. And that's really what we're very heavily focused on, is to provide this to industry and, again, to the general public at large.
Great. Well, let's come back to some of that data and some of the things you've mentioned there, such as the life cycle analysis, a bit later. Ian, perhaps you can tell us a bit about some of the themes that you've been discussing and the insights from the WEF, please. And I understand you might have a couple of slides to show us on this as well.
Yeah, absolutely. I'll launch those in just a moment. Maybe just to very quickly, I think one, the comparison that Emma gave, I think, is a very provocative one with efficiency and effectiveness. Although I would maybe disagree slightly in that I think it paints a picture that the current way of doing things is entirely negative, and that I think it's important that we focus on the effectiveness, but that doesn't mean that efficiency gains are something that people shouldn't strive for. And so I think that's where perhaps the comparison or metaphor might fall apart a little bit. The slides that I have here are really looking at what we started as a piece of work. What happened last year when the pandemic began to hit, and how did that begin to see? How did we begin to see some transformations within the industry of how companies were thinking about technology at large, and then I'll get into how I think that's going to relate directly into the additive manufacturing 3D printing space and sustainability at large. There's a lot of information on a slide like this. I think one thing that I really just wanted to point out here is that we spoke with over 400 executives of supply chain from companies all around the world. And I think both Emma and Sherry brought up this idea of distributed manufacturing models, and I think that's when we see that 44% right in the middle of the screen of adapting distribution methods. That's where we're going to see that start to come into play, and where it's really important when we think about the impact of distributed manufacturing models, both for the impact on additive manufacturing, but also the sustainability of supply chains. And I think Sherry brought point that we still need this very concrete research of the process of additive. How much is it really impacting the sustainability of the products being produced? But I think what we do know is when we shift to these distributed models, we already have a direct, and excuse me, Emma, but an efficiency gain in the transportation of goods, because we're able to create shorter supply chains, at least for parts and elements that go into our manufacturing models. Obviously not for everything. Very quickly, I'll run through a couple of these things, but one of the things that we saw here is a big shift from people thinking, I need to find the cheapest place to produce the goods that I'm trying to make, to seeing what happened when the pandemic hit, of the challenges and the greater risks that come along with a lack of a distributed model in your manufacturing supply chain, to saying, well, it's not just about cost competitiveness, it's about risk competitiveness, and we need to find a balance there. But that is a challenge that is not an easy one to crack. What we do know is that from the companies that had invested more into advanced manufacturing technologies like 3D printing, they have fared better and been more resilient through the pandemic. So I think that this is a great reason, whether we're thinking about sustainability or the viability of our companies over the long run, why technologies like these are so important for people to spend more time in, and why I think it's amazing the work that Sherry and Emma are both doing around this, because we need better understandings, and we need to help companies and individuals understand how these can actually make the systems that we are using as a whole across the global economy work better and also work in new ways. I think that the last thing that I just wanted to touch here, and then I'll pause, I know I'm rambling on here, is that we think that there's really 4 major shifts that we think are going to stick around and be a major part of the future that happened over the last year. And sustainability is one of those key shifts. Companies have realized that they can't continue operating the way that they have, and we need to find new models of doing it. And I think that's, Emma brought this up. It's not just about only finding the efficiency gains. It's about reinventing and reinventing those systems and ecosystems where we operate to find new ways of doing those. And I think companies are realizing that's a necessity now.
Mm-hmm. Excellent. There's a couple of things I'd like to come back to in a moment, in particular the response to the pandemic. But you mentioned distributed manufacturing there, and Emma, we were talking before about how you've identified the centralized nature of traditional manufacturing as a challenge to sustainability. And I think it's interesting to kind of understand why distributed manufacturing may present a solution if we look at why centralized is a concern. Perhaps you could maybe elaborate on that a bit, please.
Yeah, I think Ian explained really well, actually, the implications of a very centralized and globalized supply chain, which, you know, it was really exposed during the beginning of the COVID-19 pandemic, where we even had very simple products with, you know, supply constraints. And this is, you know, a symptom of over dependency of just a few players in the market. And when that falls apart, you have really massive consequences. And I think that was very useful in revealing that problem, actually. So if we look at very centralized supply chains, and just getting back to the point of Ian around efficiency as well. So there is a time and a place to be efficient. And there's also a place for highly efficient and globalized supply chains. If you look at effective systems in nature, they always balance out a feature of efficiency with a feature of resilience. So the efficiency, we got that. Resilience means like a more distributive, niched way, smaller scale, localized way of, you know, in this case, production and manufacturing. Now, I think that in general, one of the reasons why we have highly efficient globalized supply chains is because venture capitalism really kind of reinforces, you know, like the extractive nature of that, and gives a big incentive to focus on that as an economy. Now, I do think we should balance that out with a more resilient feature. And that's why I'm very interested in that specific topic, because we should develop that further and look at what the systems conditions are for such a system. And I do think that 3D printing and additive manufacturing have a very big role to play in that space.
Well, yeah, going back to you, Ian, and Emma's talking about resilience there. If we're looking at resilience of supply chains, well, maybe that wasn't the case during the early days of a pandemic, and AM did step in to provide solutions for PPE, for example, and even for ventilators or respirators. Perhaps you could just highlight a couple of the lessons that we can learn from the COVID-19 rapid response and how that illustrates distributed manufacturing in practice, please.
Yeah, absolutely. I think that, I mean, Emma hit it perfectly on the head there, that you need this balance, and that when we realize that the pendulum is swung too far one direction and something like COVID-19 happens, it exposes the frailties of the global system. So, you know, from what we saw, we launched an initiative on the 3D printing COVID-19 rapid response that brought together some of the largest additive manufacturing in the world to try to support one another. I mean, the additive manufacturing industry as a whole, I know there's probably a number of you on the line now. I mean, my hat is off to this entire community, because it really stepped up in the early days of this pandemic to fill a need. I think what was critical and what we saw is where these elements of collaboration and cooperation are instrumental, is that while someone can share a file of how something can be printed very easily, there's a lot that goes into that. And I think that's where the understanding of what the material were used, the process by which it was actually printed. We need to be thinking, depending on the sector. In this case, in COVID-19, we're talking about printing things that were going to be used to try to keep other people alive. And it's really important that if you're going to do that, that you get it right. And so that was perhaps one of the lessons that we really learned in working with this community, was an overwhelming sense of responsibility to help identify and support one another and understand where there was a lack of supply to fill the demand, but making sure that if the community was going to pivot and support that it was going to do it in a responsible way. And that was, I think, one of the things that the community was really focused on in that moment of time.
Yeah, and I know there was a lot of conversation about the responsible ways to do this, dealing with medical, additive industry isn't a stranger to that, so they appreciate the dangers of just jumping in with both feet without due consideration. But Sherry, I'd certainly like to bring you back into this, and this is really a question for everyone, but we'll start with you, Sherry, on this. I think. What are your thoughts about on-demand and distributed manufacturing, and how can those methods of organizing production tackle issues such as reducing carbon footprint?
Well, in terms of carbon footprint as an example, last November, the AMGTA published our first commissioned academic research paper on sustainability in AM metal. And this report actually looked at the carbon footprints of AM, because the LCAs, again, the life cycle assessments that were available in the industry literature or in the academic literature were limited to just CO2. Measuring CO2, and a good life cycle assessment will look at 18 environmental impact categories. So because the research is limited, it really, was focused on carbon footprint. So I can certainly speak to that. So when you look at the carbon footprint per kilogram of any conventional manufacturing process, there are lots of databases. So our researchers used one of the best, which is the Granta's CES EduPack. But it has no data on AM because there aren't enough LCAs out there. So to compare the impacts of metal AM to conventional manufacturing, we had to compare LCAs of AM published in academic journals to the Granta database. So that's currently how it is. So if you compare the processing engineering impacts of AM to casting, extrusion, rolling, forging, or wire drawing, anything except machining, you'll see that AM has between 5 to 100 times the impact per kilogram, depending on the metal processed. But 5 times is very different from 100 times. So why such a wide range? And partly this is because conventional manufacturing methods have very different impacts from each other, and partly because these very studies have been done on metal AM's carbon footprint, much less directly comparing it to other manufacturing methods. So we really don't know how repeatable these numbers are, and more studies need to be done. But you might be reassured to hear that if you measure not just the processing energy impacts, but also the embodied impacts of the materials themselves, the ratios go way down, which is a good thing. So if you look at, for instance, 3D printing steel is only 4 to 8 times the impact per kilogram of other processes, and titanium is only 1.4 to 1.7 times. So it's important to note that these numbers are really design agnostic, meaning that operational improvements in design, such as weight savings or a combination of traditional manufacturing steps, are excluded. So if you look at like a solid metal cube, does anyone really think that AM is the best, most sustainable way to manufacture that cube? Of course not. So the true power of AM is really in the design and the final part geometry aspects that a basic fabrication comparison such as this really does ignore. So it's a critical distinction because we really need to study at length the use of life cycle analyses where intricately designed and optimized components manufactured additively can be compared, fairly with traditionally manufactured components.
Well, let's get into that in a bit, but just the final bit of, if you like, our kind of theory section or our concept section, I think it's important to talk about the circular economy as well here. And looking at that bigger picture, Emma, perhaps you could maybe tell us a little bit about that and how you would locate additive manufacturing within the circular economy.
Yeah, so I think that using 3D printing for things like repair and maintenance and different ways to extend product lifespans is really interesting, but not the most interesting part of this technology. I am a big proponent of fab labs and maker spaces. And they also say if you cannot fix it, you don't own it. And I very much like the empowering nature of it. And maybe this is like a discussion for later, because if we look at the circular economy as a whole, it's an economy that learns from living systems. And if we take a forest, for example, and we look at a tree uses resources that are locally available, such as water, carbon dioxide, nutrients from the soil, sunlight, and it provides a wide range of benefits, such as also shelter for birds, generates oxygen for us, and maybe also fruits, and that can feed animals and creatures. And at the end of its lifespan, a tree dies and becomes one with the soil that it once stood on. It provides food again for other plants and creatures. And can you ever imagine in a context like that, having a centralized supply for something that works as effective as a forest? The energy cost and the logistics, it's just incomprehensible. If you look at the amount of activities that you see there and the amount of benefits on all these layers, if you would do that in a very siloed way, you cannot ever justify the energy and the costs compared to that. So I think Kate Raworth says this: Mother Nature would laugh at us if she would see, what we're doing with our, highly brittle supply chains and overly depending on that. And additive manufacturing and 3D printing allows us to operate a bit more like trees do in a forest. And it can also provide access to means of production to more remote areas and rural areas. Often this discussion is held in a very Western and well-off environment. But if we look at a more globally inclusive economy, like if we look at these rural and remote areas, we can give them access to be in control of their own production, and ultimately leading towards more independence. And I do think that this is where it truly gets interesting, because if you also then would consider moving away from petrochemical polymers and focus on maybe locally abundant and natural materials, and it is possible to use these within 3D printing and additive manufacturing, you could connect the supply of those materials to actually the needs of local communities. And my key takeaway here is that in the end, it's all about context. It is about okay, yes, we have this technology, but what does it actually do in a very specific situation? What does it do to the economy, to society, and the environment on all these three levels in connection with each other? That's what we should evaluate, and what the circular economy debate is all about.
Excellent. And some of those ideas you're expressing there definitely reminded me of the old philosopher Kropotkin from about many years ago. But anyway, let's get into the next part of our conversation now, which part 2 is going to be talking more about. Gosh, I pressed the wrong button there. I do apologize. Okay. Well, part 2, yes. Part 2, we're going to be talking about validating AM as a sustainable technology. So we've talked a lot about the concepts here, but actually getting down to the nuts and bolts of this. And Sherry, you were talking about looking at CO2 comparability between different technologies. Maybe we can talk a bit more about that ecosystem approach, though, that Emma was describing there in the idea of a circular economy. And in particular, perhaps you could tell us more about the about what is a life cycle assessment? How does that fit into this, and why is that a useful way of approaching gathering data here, please?
Sure, happy to. I'm just going to pull up a slide here to help give a graphic to what is an LCA, life cycle assessment, and then I'll just define it a little bit better for people. I'm trying to pull up the slide here.
I think maybe I kind of messed up your slides by trying to open up mine. So
yeah, it wouldn't allow me to. So I'll try again.
Try again now.
It's not pulling up.
Okay. Well, I'll try and launch that. But
Okay, that'd be great. Yeah, I can talk about it. Oh, perfect. You got it. Okay, as I mentioned, there's limited published research that actually considers life cycle assessment, which is a comparative study of the environmental impact a part or a product has throughout the stages of its life from cradle to grave. And Emma was talking about cradle to cradle, which is the circular economy concept. And there's a distinction here because the current linear system is really focused on make, use, dispose, pollute, whereas the circular economy is focused on make, reuse, reduce, recycle, repurpose. And so there's this constant flow where material just gets repurposed and it's not ever thrown away. But in terms of life cycle assessment, we're looking at cradle to grave. So the AMGTA is addressing this lack of real research by commissioning studies that include life cycle assessments. So LCAs analyze a part at each phase of its life, from raw material extraction, processing, manufacturing, transportation, use, and disposal. An LCA means fully considering, again, what it takes to produce a part or a product from raw material extraction, processing, production, assembly, transportation, and all of the other steps that I haven't even mentioned here, up and through the part or product's eventual end of life when it is no longer considered useful. And again, this is the cradle to grave concept, not the circular economy. So unfortunately, most of what's produced in the world today, I think it's the World Economic Forum, and Ian, you can correct me if I'm wrong, says currently the circular economy only is 8.9% of the world economy. So the rest of that is really operating on this cradle to grave type linear consumption model. So we want to fully understand what the environmental impacts are all along the way, from raw material extraction to end of life. So our research is going to determine at a granular level what amount of AM is an environmentally improved manufacturing process. And this spring, the AMGTA is commissioning our first life cycle assessment project with a major U.S. university to compare an aerospace component manufactured using a traditional casting or forging process versus that same component optimized for powder bed fusion additive manufacturing.
Interesting. So is that a critical component there, or is it structural, or what kind of component? Can you say anything about that?
It will be a nozzle guide vane, I believe, is what we're really focusing in on, and that seems to be where the project is going. So yeah.
Right. I look forward to seeing the results of the work there, because absolutely this is what's needed in the industry to really have a solid footing to stand on and build the business case and the sustainable case really for why implementing this technology can be important. Perhaps Ian, you could tell us a bit more about the initiatives the WF was working on, and there's one in particular that caught my eye, which was the accelerating sustainable production through digital traceability. And maybe you can sort of explain what that is, and maybe why standardization is also important in understanding these topics.
Yeah, absolutely. I mean, I think that the idea of the traceability initiative, the accelerating sustainable production through digital traceability, again, no points for being concise on our title names there, but is really to try to address what Sherry was just talking about in the LCA and sort of the ideal of more of a circular economy. And that's we realized through a lot of work that we've done over the years that most companies have terrible visibility into their supply chains. And so there's one thing about using traceability to look back upstream and understand where your products came from, that there's huge sustainability benefits there. Now, going to Emma's point before, if you shorten that supply chain, it gets a lot easier. If you have a more distributed model, it becomes easier. But traceability is really still a key element when you look upstream. But if we want to end up closing the loop and be able to transition from what Sherry was talking about, of that cradle to grave to cradle concept, you have to be able to extend that traceability all the way up to and through the consumer. And so what we're really looking at is how can we do that to enable new models of reduce, reuse, repurpose, recycle, remanufacture that enable not just a way of understanding that I know which landfill my product ended up in, but how do we actually bring that back and make sure that we're extending products as long as we possibly can. And that's really what we're focused on. And I think the idea there and how it's tying into additive is that we really see that I think additive is a piece of the puzzle here. And so that's where I see it fitting into, people can talk about within traceability, maybe less so now, but the huge buzzword for years was blockchain. I think most people in the industry would agree that blockchain is a wonderful technology for some things, not necessarily for everything. And similarly, as Sherry pointed out, I mean, you have huge gains that additive plays in some elements and maybe less so depending on what you're making. And so that's really what we're trying to do is how do we help companies understand where the technologies can fit in the best to provide the best benefit and to help them reimagine the ways that we do this.
Mm-hmm. I had to smile briefly when you mentioned blockchain and we're talking about sustainability, just thinking about the sheer amount of energy that's consumed to validate the Bitcoin ledger it's larger than some countries now, I think, isn't it?
Although fortunately, not all blockchains are Bitcoins. There's not mining involved in all of them, so that's at least the benefit there.
I think, Bitcoin specifically, isn't it? It's very much
exactly.
A large consumer. But
I do have a quick question for you, Ian, because I do think that conversation around traceability and transparency of like what is actually in the material is super important. And I've spoken to quite a few companies about this, and there's always such a massive barrier in terms of like IP. Do you have any ideas about like how to address it? Because I surely don't.
No, that's exactly what we're working on within the context of this is how do we leverage different data ecosystems and how can companies protect their own IP but also share the chain that some of this is. So the idea here within traceability is perhaps there's a way that we can leverage the technologies that are enabling traceability and pull out the sustainability metrics, which theoretically could be part of the global commons that everyone should be willing to share to get a much better of that scope 3 emissions across the entire supply chain. And so, a lot of this goes back to the importance that we put on collaboration across industry, and how do you begin to shift the mindset inside of a company to understand that sharing some data doesn't necessarily mean I'm sharing my secret sauce, my IP that's going to give away my competitive advantage. And so for a lot of time, people said sharing means I lose everything. And now it's how do we begin to develop frameworks that say, actually, you can share some things and maintain your competitive advantage. And you mentioned the three sort of the pillars of the economics, environment, and society. How do I keep my economic benefit while still being able to support these other pillars? And so that's absolutely something we're working on now.
A good question. And also just a reminder to everybody watching and listening, you can also ask questions at any time you like in the chat, and I'll get to those as quickly as possible. Sherry, back to you though. AMGTA recently published the results on I think it was as metal and sustainability, wasn't it? It was additive manufactured metal and sustainability, and it was a literature review paper. Perhaps you could tell us a little bit about what you found there, please.
Sure. That paper is available for free. Anybody can access it on our website at amgta.org in the resource section. So we commissioned this paper with Dr. Jeremy Faludi from Technical University of Delft. And it was a systematic review, as you mentioned, of the current research literature regarding sustainability of metal AM. And what we found was that, unsurprisingly, there's not enough good research, and I talked about that earlier, to really fully capture all of the aspects of AM as it relates to sustainability, and especially not enough research to compare the impact of an additively designed part to one that has been optimized through the virtues of AM, or one that has been optimized, I should say, through the virtues of AM with a similar component manufactured using traditional methods, comparing really, truly the differences between the technology. So optimization is really key. Otherwise, you're not really capturing what it is that makes AM so great. And so this motivates us as an organization to start developing good research that examines these improvements. But part design and end-use utility notwithstanding, Dr. Faludi was able to put basic facts regarding metal AM as a manufacturing process versus conventional manufacturing. So key findings from the report include that while metal AM generally has a much higher carbon footprint per kilogram of material processed than conventional manufacturing. I talked about that earlier. When considering the direct manufacturing process itself, but impacts depend greatly on part geometry. So a solid cube has a much lower impact to produce by machining, while a hollow shell or lattice can be lower impact to produce by AM. So the report further recognizes that the need for additional life cycle assessments to quantify environmental impacts, and more LCA studies are necessary to definitively compare metal AM to conventional manufacturing, especially direct comparisons to AM and machining, and for technologies such as binder jetting and direct energy deposition. So these LCAs really need to include more of the product life cycle. And as I mentioned earlier, the LCAs that are out there really are focusing on carbon footprint, but there's so much more. There's 18 categories of LCA that can be analyzed.
And is there a particular reason for focusing on metal at the moment?
Well, we had to start somewhere. And when you look at in the early days of the organization, now we have 19 member companies. Earlier on, when we were commissioning this research, we had a smaller number of companies, and it was heavily AM metal focused.
Right.
We are much more diverse as an organization, so we anticipate that we will truly be representing the industry by looking at different materials, of course, polymers in the future. So again, this was our first project, and we expect to do more as we move on and as we grow as an organization.
Excellent. So Emma, you were talking much earlier about the need to move beyond talking about just efficiency-driven applications or extending the life of products via spare parts. Actually, this microphone I've got here, this part is 3D printed, which there's a fastener which broke and I've replaced it there. So you know, it's in practical use even here. Perhaps you could talk a bit more about those ideas of efficiency, but also about democratizing the means of production via these local and contextual materials that you were also mentioning.
Yeah, so 2 key points. So one, yes, there is a place for printing your own little stand for your microphone that is exactly accustomed to your specific needs. But if we look at just replacing, you know, spare parts, etc., we're still operating in the same system, right? In the same linear economy that Cherry already addressed. And like if we, for example, look at replacing spare parts from cars, you know, that will probably be necessary for a very long time. But it's actually also more important at this moment to address, you know, what does mobility look like and what is then the role of this specific technology in the changing landscape of, for example, mobility. So it's also like acknowledging that the problem is much wider than just, you know, there's this part that is failing. Because if we're looking at sustainability and we want to make progress in that space, you cannot just, you know, extend the lifespan of current products. What I do acknowledge is that the technology itself is empowering. You can, you know, 3D print your mic stand, etc. But when we completely rely on petrochemical polymers for printing, like, yes, there is a time and a place for that. But most materials in circulation on this world are biological materials, and for a good reason, because they are not shedding microplastics like every wash or every use. And they, you know, like they are designed to, you know, cycle and to regenerate. So I think that there is a very, you know, a big priority for us all to explore what biological and natural materials could do for us, and also fit the material with the context in which it's being used. If you, for example, work with a company that designs heavy machinery, you're not going to make stuff from like carton bits or eggshells or something, and you will be looking at metals. But if we're looking at small consumer products with a very short lifespan, why are we using plastics for that if they will be reaching their end of life very shortly after it started? So I think that also, like, you have some people that are addressing this more systemic nature of the problem and addressing natural materials in the context of 3D printing. And just wanted to highlight two really interesting champions in this area, Alicia Garmalewicz and Liz Corbin, and they launched their platform. It's called Materiam.org. And it's like nature's recipe book. So it looks at like natural materials. And if you go to the materials library and you click on 3D printing, you will actually get a series of recipes for materials that you can make in your very own kitchen that you can 3D print. How cool is that?
I did check it out, and yes, they are indeed there. And this particular sort of plastic washer I've got on the microphone stand, it's made from PLA, which is not an oil-based material. It's still, even though it's based on corn, I think, cornstarch.
Yeah, but
is it actually compostable? Is it really sort of how long is it going to take for that to degrade? It's got to be put somewhere when it inevitably breaks. And I think that kind of leads into where we're going with what I'd like to talk about, which is, what are your thoughts of everybody here about greenwashing, and what can additive learn from other industries to avoid this?
My thoughts or someone else's thoughts? Okay, I will kick it off. But like, look, if it's not like, basically, if sustainability or the sustainability department is just sitting in communications within a company, that's kind of a sign for me, like, okay, they are not taking it seriously. You have like, so this company, I love this company. It's an outdoor company called Keen. They're based in Portland, Oregon, and they do amazing things around detoxing their supply chain. So taking out all the toxins, and they don't talk about it because they're like, this should be normal. We're going to integrate this. I don't have to scream this off the roofs. This is the new normal. And I think that shows a lot of integrity and priority, and it's being integrated across the entire company. And I think that's a great example of like what we ideally would like to see. If a company is very screamy, I always look at where their sustainability department sits.
Good points. And I'm not going to sort of name names on companies I think which do a very good job of this, but also ones who've got a very powerful comms department. So I'm staying out of that one. Perhaps Sherry, could you tell us?
Yeah, there's a really good research paper. I'll put it in the chat box that I recommend on greenwashing and this phenomenon used by companies to promote and sell their products. And it's called, "Are You Environmentally Conscious Enough to Differentiate Between Greenwashing and Greenwashed and Sustainable Items?" And that research noted that, unfortunately, some companies choose to intentionally mislead consumers by using marketing and advertising strategy claims that they are green, but they actually lack implementation of any real practices that could reduce their adverse environmental impact. And it was largely found in this research that these broad claims are made because it is not in the best interest of these companies to reduce their environmental performance or share any of these results with their customers. So transparency and data is needed to back up environmental claims from any company, whether it's product packaging or it's the actual materials that produce the product, whatever it might be. There's so many different ways you can go with this. There's a lot of sustainability metrics that could be reported, and companies need to be able to show their customers actual case studies or research examples that support these claims, these green claims. And that is the real reason, very real reason why the AMGTA was formed, was to produce research for the industry that's rigorous, ongoing, and independent, so these member companies can validate the claims that they're making to their customers and their end users.
Excellent.
So I'm going to pop that link right in the.
Pop that link in the chat, and also in the chat we've got a questions come up as well. I'm see if someone wants to tackle this one, but we've been asked, what is the role of governments and regulatory agencies in helping the private sector in promoting AM for sustainability? Is there a role for the government and regulatory agencies to be doing that part of promotion of AM for sustainability? Sherry, perhaps you have some thoughts on that, as you're probably closer to AM than our other guests.
Yeah, I think one of the areas you're seeing regulation in AM is on emissions. And, certainly there's some real concerns, and I'll speak to AM metal because that's where the biggest concern seems to be in terms of employees in manufacturing plants actually ingesting the particles in the metal itself. But there is protective gear that companies mandate their employees wear. But even so, when there's the possibility of it being in the air in between shifts and the gear is not yet on that person and it's in the air perhaps, but there is, filtration with these pieces of equipment, et cetera, et cetera. But what is the real risk? And companies are starting to regularly check the blood levels, the blood content of their employees to be sure that they're not getting toxins in their body as a result of their working for the company. So it's very interesting to see what's happening. But I think that there's certainly more that needs to be done in terms of protecting employee health and safety. So that's just one area that we're starting to see some regulation come about. And I think that in terms of CO2 emissions, there are some really strong messages coming out of different countries, and in particular, of trying to regulate CO2 emissions in manufacturing.
That's not necessarily strictly only to additive manufacturing, though, is
right?
It?
Exactly.
So, yeah.
Exactly.
This is something you mentioned briefly earlier. Perhaps you could tell us a little bit about biomimicry and how it relates to additive manufacturing or 3D printing.
So she looks at biomimicry, and she's inspired by nature, and she also really addresses the role of 3D printing. So anyone who's watching this, it's really interesting to just look at her work, Janine Benyus. And basically, in essence, if we look at biomimicry,